Here, the first thing that we want to do is to get in our data. And our data here is going to be on abundance, B abundance. And we want to create a data frame such that it records 10 abundances for male and 10 abundances for female. So these are the abundances that were recorded for the male. So we are asking R to create the data frame, and for that data frame, create a column named gender, and under the column, replicate male 10 times. And for that column, give it the abundance of these numbers we have provided. And we are doing the same for the female. So we just run this code to see what we get. I want us to view it before we continue. So view b.data to see how our data is structured. Beautiful. So we have the data structured in a way that records male and the abundance. So, and it records female 10 times, and for each gives it the abundance. Okay, so if you want your data to be arranged in this format, that is a code you can use to just keep your data arranged. And we want to save the data. I always do that because you don't want to go into that stress of having to write or read in the data, like write the code all the time to get your data. So I'll just save the data so that just in case you want to come back to use it again, you don't go through that. If you want to see that your data was saved, when you go into your data subfolder, you can see that the data has been saved. We would check whether it is parametric or non-parametric. So for a parametric data, it means that it follows a normal distribution. And for a non-parametric data, it does not follow a normal distribution. And one way that you can use to check that is by using a QQ plot. So we would run this QQ plot and check it. So mostly if you see like a very distinct shape in your QQ plot, it could mean that it is not parametric, like it is not normal. But there isn't that much of a distinct shape in the plots. The plots kind of looks like it is like well distributed on the line. There isn't that much of a distinct shape. Mostly if you see like that S shape, you know that it is non-parametric. So from this plot, I can conclude that the data we have is parametric. But we are going to continue. Let me save this. Let me save this plot here. So QQ plot. That's our QQ plot. Okay, now we are going to test that either it is a parametric or non-parametric using the statistical data, using the statistical analysis to check. So now we are going to use a statistical test to check whether it's parametric or non-parametric. And one of the ways you can do that in R is using the Shapiro.test, which simply stands for the Shapiro wilk test for normality. So we are going to choose our alpha value of 0.05, which is our significance level. So beyond or above this, above or below this, we can either state that our data is normally distributed or not. So we run this on our abundance and let's see the results we have. So we have a p-value of 0.689. So the p-value we had is greater than alpha, which means that we would have to fail to reject the null hypothesis and hence conclude that data is parametric. So when your p-value is greater than the alpha, you fail to reject the null hypothesis, and it means the data is parametric, because in the null hypothesis we say that the data is normally distributed, which means that it's parametric, and non-normally distributed means that it is non-parametric. Another test you can run is the Anderson-Darling normality test, and you do that using the install packages null test. That this particular function can be found in the null test package. Here we just call it from the library and then run it again. You should get a similar result. Yeah. So here too, the p-value is greater than 0.05. The first one was 0.689, running it with a Shapiro wilk, and this gave us 0.615, 6151. So it means that it is still saying our data is parametric. Okay,